we want to look at the basics of the Argand diagram. So this video is going to focus mainly on the basics of the Argand diagram. So an Argand diagram is a geometrical way of representing a complex number, either as a point or as a vector in two dimensions. Okay, so we look at it as we have the normal Cartesian plane, but now our 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 vertical axis is now representing the imaginary part of the complex number, and our horizontal axis is now representing the real part of the complex number. So if we are given a complex number x plus yi, right, the x is representing the real part of the complex number, the y is representing the imaginary part of the complex number, right? And this can give us the Cartesian coordinates for our Argand diagram. So if I have 3 plus 4i, this part, the 3 is representing the real part, the 4 is representing the imaginary part of the complex number, and this gives me the coordinates 3, 4. Now these are Cartesian coordinates, right? So when we want to represent a complex number as a point, all that we need is just these Cartesian coordinates. So if I have the point 4 plus 2i, the 4 is on the real axis, the 2 is on the imaginary axis. Where they coincide, that's where the point 4 plus 2i is. Let's move on to minus 3 minus 3i. So the minus 3 is on the real axis, right? This is the minus 3 on the real axis, and minus 3 on the imaginary axis, we have the minus 3 on the imaginary axis. Where they coincide, that is where the point minus 3i is. And we move on to 2. We want to represent 2 on an Argand diagram, right? So 2 is the same as 2 plus 0i, right? So we have the 2 on the real axis, and then we have the 0 on the imaginary axis. So it just means that our point, it lies on the real axis. So this is the point 2 plus 0i. And we move on to I is the same as 0 plus I. So it means we want the 0 on the real axis, right? And the 1 on the imaginary axis. So this becomes the point. Okay, so now we want to move on to representing the complex number as a vector. So we're going to represent a complex number as a position vector, and I'm assuming that you know that a position vector, it's a vector with respect to the origin, right? So when our vectors, they are going to be linked to the origin. Okay, so if I have the vector z1, which is 3 plus 2i, I'm going to mark the point 3 and 2. This point is 3 plus 2i, and we have to connect it with the origin since we want to represent this complex number in position vector form. So we have to connect the origin to the point that is representing the complex number, and we indicate with an arrow from the origin to the complex number. We do the same for z2. z2 is equals to minus 2 minus 4i. So we have our minus 2 on the real axis, we have our minus 4 on the imaginary axis. This is the point, right? And so this is minus 2 minus 4i. And you need to take note of the arrows. They start from the origin going to the point, to the complex number point. The same, we start from the origin and the arrow is pointing to the point. Okay, so we're going to be using this knowledge when we want to represent the roots of an equation on an Argand diagram. We may be asked to show the roots of an equation on an Argand diagram. So what you just need to do is you solve the equation and you draw a quick sketch, only adding essential information on the axis. By that we mean if I want to plot the point 3 plus 2i, right? Take note that I didn't indicate the 1, the 2, I didn't indicate the numbers between the 0 and the 3. I didn't indicate the numbers that are after 3 because they are not important, they are not essential to the question that I'm responding to. I just need the 3 and I just need the 2. So when we are making our sketches, there is no need for us to be adding some additional information. We just make use of the essential information that is important to the question that we are responding to. All right. Now we need to know how to use the Argand diagram to visualize Z1 plus Z2, modulus of Z1 plus Z2, and the modulus of Z1 minus Z2. So take note that Z1 and Z2, these are complex numbers, right? So we are given a situation whereby we have two complex numbers and we want to represent the modulus of their sum and we want to represent the modulus of their difference. So this is just a summary of how we do it. We plot the two complex numbers Z1 and Z2. We draw a line from the origin to each complex number. So in other words, we're going to represent our Z1 and Z2 as position vectors, right? And we need to form a parallelogram using two lines as adjacent sides, and the modulus of their sum, Z1, Z2, will be the length of the diagonal that is starting at the origin, and the modulus of the difference will be the length of the diagonal between the two complex numbers. So to explain this further, we need to look at a diagram. I think you will understand better when we have a diagram. Okay, so let's look at this diagram. All right, so we are having our Z1 and we are having Z2. These are complex numbers and we have to represent them first as position vectors. So I have this red line here. Can you take note that it is starting from the origin, right, to the point Z1. So this is my position vector for Z1. And then I have this vector in blue representing Z2. Okay, so I have my Z1 and I have my Z2, right? The next thing that I have to do is I have to form a parallelogram. I have to draw lines that are adjacent to Z1 and Z2 in such a way that we form a parallelogram. So we have this line and this line. So these two lines, they're just helping to complete a parallelogram. So this line here is parallel to Z1. Our Z2 is parallel to this top line. Okay, so now we have our parallelogram. What you need to understand is for modulus of Z1 plus Z2, this is the diagonal of the parallelogram that is starting at the origin. So this is the one that is in green. So this is modulus of Z1 plus Z2. And then the other diagonal that is connecting Z1 and Z2 is now representing the modulus of Z1 minus Z2. So in a nutshell, what I'm saying is when I have modulus of z1 plus z2 and modulus of z1 minus z2. These two can be represented on the same diagram, right? As these are just diagonals of a parallelogram. So we have our parallelogram that is being formed using z1 and z2. The diagonal that starts from the origin, right, and it is going to the other side of the parallelogram, that is the one that is representing z1 plus z2. And the diagonal connecting the two vectors is z1 minus z2, is the modulus of z1 minus z2. Okay, I think that part you understand. Let's look at an example. Okay, let's look at an example. We have z1 is equals to 2 plus 2i, and z2 is equals to 3 minus 4i. We need to show the complex number z1 and z2 is points on an Argand diagram. So I think this one is a bit, it's simple. So we have our Argand diagram here, and I need you to take note that our Argand diagram is just showing the important information with regards to the question that we're considering. So we have z1 is equals to 2 plus 2i. We have 2 on the real axis and 2 on the imaginary axis. So this is our z1. This is just a point. We are not going to connect it to the origin because the question says we should represent as points. So we are not going to connect it to the origin. And then 3 minus 4i. So we have 3 on the real axis and we have minus 4 on the imaginary axis, and so this is our point, and so we are done. And on the Argand diagram below, 2 points A and B have been plotted. State the complex numbers that are being represented. Okay, so let me just okay, so we want to know this point A and the point B. So our complex number, we know it's of the form x plus y I, right? So the x is on the real axis. So for this one, it's a minus 2. And the imaginary part, we have a minus 1. So it's minus I. So that's A. And then for the second one, for the B, on the real axis, we have a 1. And on the imaginary part, we have a 3. So that is 3 plus I. So those are our coordinates for A and B. I'm sure that is easy to understand. So just an exam tip, when setting up an Argand diagram, we don't need to draw a fully scaled axis. You only need the essential information that shows the important parts of our question, and that will save us time. Thank you very much for watching.